See. Let me open it. Oh, what? Okay, I see it now.
Okay,
Can you
so
hear?
yeah,
Okay.
okay,
Okay.
so basically, I did what you told me with like lithium. For example, I divided the amount of samples that we had, and I used half of it to come up with the T value, and the rest of them to get the true mean, which will be the top one. And we were like using like a
What
fake
do you
one,
mean? What do you mean? Rest of them?
like all of them.
All of them. Okay.
All of them for the true mean and half for not I mean for like the deep value. And yeah, everything is perfect in regards to this, right? I believe. Yeah. But here is what has me
Uh,
tweaking a little bit here,
I'm
right?
not sure. I'm not sure if everything is perfect. So, your x-axis there is that z or is that or not z? Is that t values
Where?
or is that actual
Where?
the x-axis? So the axis that goes from like -3 to 3.
-3 to 3.
Yeah,
Uh,
the x-axis.
what do you mean with the
Um,
x-axis?
so like for example, um, let's see. Okay, so what's okay? So t value -5.69.
Okay, apparently this is meant
Is,
to
is
be
that
the deep value if like we use the like 6n. I like the t critical value is meant to be this one. And
okay? So that because there is a difference between mu and t. Like how should I put it?
I
Um,
know.
like
No, but like
the unit uh,
go on.
the units of the x-axis are t, are the t statistic. It's like 0 is 0 t statistic of 0, 1 is t statistic of 1, 2, and then like at let's say 0.54, that's t critical. So if as you go up and down, that from -3 to 3, that's the t value, t statistic.
Yeah. So
Um,
you think that the
so
deep
so that
value in the upper one is wrong, or what do you mean?
so that mu
I mean
equals
t
zero
crit.
point zero 0.04.
Yeah, that's what
Huh?
you told me. Yeah. That like the true mean here
So
is like the average of like the what I was gonna say, the all the lithium samples, like you said yesterday that you wanted to get.
wait, what?
Yeah, you said that to me
Okay, now
yesterday.
I'm getting confused.
So yesterday you said to
uh,
me that on the true mean
yeah.
you wanted me to grab all the samples and put the mean here. I mean, like put the number here of all the average of all the samples here. Is this what you said yesterday?
Yeah, but so uh, I mean, don't they look kind of really close? Like, why are they so close? The 0.04 and 0.041.
Zero.
Because
Because this is like the true mean, and this I mean what was I gonna say? Sorry, this is the true mean, and this one is meant to be like fake because the real true mean will be this one, and what I'm trying to like represent is that okay, you know, in reality the true mean is this one, and we should be fucking not failing to react and all, and uh you know, go along with the alternative hypothesis or alternative true mean, and we'll be
so can you
committing a
show
type
me
2
like
error.
so the true mean is supposed to be
Uh,
uh
I mean, what you explained me
all the
yesterday, yeah. Okay, go on.
All the days when after I took lithium, the health index after I took lithium.
Uh, what do you mean? Like, didn't you say when you took lithium? You said when you
But
took
after,
lithium.
not before.
No, not before.
After.
It's when you took it. I took like the samples the day you took it. Like on here on the Tramin.
It's a health index after I took the lithium. It's not before. It's the after.
Yeah, no, but I didn't take it before I took it. I took the average of the health index, the precise days that you took it. So if you took it like 12 days here, it's that days average. Like all those days combined to come up with an average of like
And on the bottom one, it's the
0.041.
day before that.
On this one?
And yeah.
No. This one is just like a not real like it's just like I just
Well,
change one digit. Like in this one, it's just like this one, but they just change one digit from like 41 to
well,
like
that one
40.
is our hypothesis.
Yeah, this one
Well,
is meant to be the null.
so the
This one
bottom
meant
one
to
is
be, yeah.
so the bottom one is supposed to be our hypothesis, and our hypothesis is bigger or smaller than the previous day. And to calculate what is the previous day, we take all the previous days before lithium and take the average of those health indexes, and that value is what we hypothesize above or below that value.
Wait, so the null is meant to be like the previous days in this one, in this case?
Well, that's the question we are asking, is that lithium will improve or make it worse the health index.
Yeah.
So we compare it to the day before, and so to get that the mu naught, we take all the days before, and then take the average of them, and that's what we use to ask our question: is lithium better or worse than that value?
Oh, okay. So okay, get it. So this one is correct, right? And this one is not. This one should be the days before.
I mean, I don't really know exactly. Like, I mean, if you show me the I mean, if you show me maybe the data, like how exactly you calculated each one,
Like in this
then I
one,
can say for sure. But
yeah.
this
So,
one would be after all the samples after I took lithium. So yeah, like on a day is the closest health index after I took lithium
wait,
is
no,
on a
well,
day.
okay. So in this one, I calculated all, like for example, in my end, all the days that you consume lithium, right? Uh, I picked
Yeah.
them individually. I came up with the average, and this is what I got because I thought that's what you wanted me to do. And this one is basically the same minus one number here. Like I just
No,
subtracted
no.
one. Yeah. Uh, because I thought that we were just
Me,
using a made up number here. But I'm asking in the top one that this is
well,
like the real average of like the 12 days. Is that correct or not?
the top one is the real average after lithium. Yeah. The bottom one is a made up one, but we make it up, and we make it up by saying that is lithium bigger or smaller than health indexes before we take lithium. And to calculate that, we take in all
The
the days
days
before
before?
lithium and take an average. Yeah. So below the bottom one is our question. The top one is just the
Oh,
average
okay.
of the effect. Yeah.
Okay, so here it will be like the days before, all the 12 days before, right?
No, it would be 6. There you're using 6.
Well, then here it is.
Yeah, so that's supposed to be the bottom one.
But I don't understand if we're using here, in this one, we're using 12. Why will we use here 6?
Because the top one is the true one. We're assuming that if we took 30 or 50, it would still be exactly the same, because we're assuming that the top one is the true one, and the bottom one is what we would get if we only had 6 points, and then we see how wrong are we when
Oh,
we only use
okay,
6
I get
points
it.
basically.
I get it.
Yeah. Like, what are the chances that we're wrong if we use 6 points, considering that in the top we know the right answer, because we used all the points in the top.
Okay. Okay, makes sense. I get it.
What's an n value?
Okay, so what I was gonna say, that's gonna be fucking confusion as fuck. So for example, uh, if you wanted to come up with the n value that sort of like correlates to both of them, right? And you didn't like fucking have it, you're meant to come up with using this formula. But the fucking results that I was getting, even though I was doing like the math correctly, is just tweaking. You know, it's like fucking wild. I don't know why the fuck I was coming up with those. So basically, for example, um, in this case, right, you add these two numbers, right, and then you get the square number out of this one. Then you get the square number of like either the sigma or the sample, right? And
So that's a z from the normal, from like the normal distribution, not even from the t-test.
this is a C critical, or like a, you know, it could be like a T critical, and then you use like the secret the C critical, right, of like your alpha and your beta. So for alpha will be this one, and for our beta or beta
What's
will
z
be
critical for beta? Uh,
it will be
is that some?
this one, and then basically you add them up, you get, and once you get the result, you get the square out of that result, and you get the square out of the what is it called? Fuck. Um, the sigma, or
Standard deviation.
the sigma or the standard deviation, the sample standard deviation, and then you subtract the mu null against the null alternative, and then you square the result, and then you divide both of the results given by the upper part and the bottom part, and you come up with the result.
Yeah, the only question is exactly what is ZA and ZB beta. I mean, is that beta like type 2 error beta, or is that different beta?
Yeah, it's beta for like type 2 error, but like the results that I was getting, they were fucking wild, you know, like I did the math properly, also fucking
Well, I don't know if you calculated Z beta and Z alpha correctly, because that one can be very confusing.
uh wait, how is it confusing? It's just basically the critical value. Like here, and it says C, it's just like the critical value of A, and like the critical value, like you're just using the critical values, nothing else.
So you just pick beta, like whatever beta you want, like whatever type 2 error you
Yeah,
want, you
yeah,
pick it,
basically.
um, and then uh, yeah, I mean, if you pick, 60% chance you're wrong, yeah, you can fucking just take one sample, and if you just take one sample, there's gonna be a 50% chance that you're right or wrong, because it's just one sample.
Yeah, but
I mean,
like the
maybe that's where
results
you're
of
getting
this
n
one, I was
equals 1.
like, I don't know if you're meant to put the dot here, but like, you know, this is, for example, the result I got for this one, for this one,
Well, that's
for this one.
well, yeah, yeah. You know why?
Why?
Because because your true population mean sits like exactly where we ask our question, basically, because they're so freaking close. So you
Oh,
need you
okay.
need 36,000 points to get your like samples, to nail down your mean so close that you can reject or accept your null hypothesis, because the true population sits like right on the question. So our question is it bigger or smaller than 0.197, right?
Uh-huh.
But if you take 10 random points and take their mean, it could be, there's a, like, because it's so close, because you're taking the points from the top curve. So the top curve is the true one. So you take 10 random points from the top curve, and their mean is gonna be like pretty much almost in exactly 0.197. And so half of the time it will be above it in the rejection zone, and half of the time it will be below it in non-rejection zone. So if you only take 10, but if you take 40,000 points, so like based on this n value, if you take 40,000 points, then there's going to be very small chance that you're gonna be wrong. It's gonna land pretty much in between the fucking 0.198 and 0.197 because it's
Okay.
40,000 points. So you need 40,000 points basically to land in that little strip
Yeah, it's like
between
the
those two.
probability, right? To land
Yeah.
there. Okay, I get it.
Yeah. The chances of
Having an
getting it right.
yeah, the chances of getting a true mean that is in between there is like is
That will give you the
36,230. Okay, I get it. And once we
that's
switch
because they're so close.
once we switch this value of the mu null for like the previous 6 days, right? We are gonna come up with a different n value.
Yeah, it should be much more reasonable because you're gonna
Okay.
have much bigger separation. You won't have to like land in such a tight.
Wait. Here, for example, uh, I should use the half. Like, for example, I don't know if not six only. Like, for example, if in one I have like I don't know, fucking 14, right? I use like 7, right? And use like half and half, right? Like upper part is like
Yeah.
okay. I get it.
Or just use 5 and the maximum number of points. I don't know, either one.
Okay. I mean, yeah, maximum amount of points on the top and like half at the bottom. Yeah. Okay. Does that sounds right?
Yeah. Well, um,
Like in the
I'm
top.
thinking maybe let's do 5 points and maximum. Yeah. So the top one would be maximum, and the bottom one would be 5.
Okay, for sure. In all of them, regardless if we're talking about the maximum points that we're gonna have at the top will be like, I don't know, an example like 20 or like 15 if there was any. Hypothetically speaking, at the bottom the same rule will be 5 all the time.
Yeah.
Okay. Yeah.
Well, not all the time. We're just doing it for a couple examples right now, just to see what it looks like for the Fisher and arginine. So we're just doing it for pretty much. I mean, like past that, I guess it doesn't matter how you do it. I don't think. I kind of want to see it at 5 points for arginine and fish oil, but like after that, you can do it like whichever way you want to.
Okay. So for arginine and which one do you want me to be 5?
Fish oil.
Okay. 5. Yeah. Okay. Yeah. But yeah, I was like fucking tweaking when I was doing the algebra and this one also fucking what I was gonna say.
But I'm not. Your
Brendan
beta is like really high.
Brendan didn't fucking even like fully like specify how to like do the one with like the fucking algebra here. Like I already know, like for example, like kind of what it means and stuff like that. But at some point, I was confused of what to do with like the sigma once you get like the square root, and then I had to like look up online and shit like that. Like, fuck, I wish fucking Brandon could like just explain that. It's just like here we just do the fucking algebra and that's it. We do this and that's it. And I'm like, okay, well, fuck you, Brendan.
There's a lot of steps to get there.
Yeah. I mean, I was getting this, except the sigma square root. What?
Maybe it kind of shows that he hasn't really done it himself from the real data. So like he doesn't even realize all the steps that you have to take before you even get there.
Yeah.
Because he's just he read it in his textbook, this formula, and then he just basically like a parrot, said the same thing, but he doesn't actually like
copy paste then like
Yeah, basically.
do this. Okay, do this. Do that. Okay, I get it. The result is this.
So
Okay, you don't even explain how to do it. Okay, thank you, buddy.
yeah, so he might actually hit the same roadblocks if he actually started from like raw data.
But like those, what I was gonna say. On regards to like, I'm curious in regards to like scientific statistics and like other types of statistics. Like, is null an alternative hypothesis used the most in the scientific field? Sorry, compared to like, I don't know, like statistics on like sports or like finances, or how does it work? Or it can be applied in any sort of like field.
Well, it can be applied in any field. I mean, the most I've ever seen it applied is medical field. I don't know,
Oh,
but maybe
okay.
that's because I spend most of my time researching and reading like medical fields. So it might be because of that, you know. Well,
Yeah.
not true. I mean, like in engineering, you know, I spend plenty of time engineering, physics, um, uh, pretty much, and none of them really use anything related to hypothesis testing.
Mm.
It's environmental science did a bit of hypothesis testing, so environmental science, but yeah, I mean, I guess it depends on the field. I mean, like, but environmental science is like kind of biology, you know, so it's
Yeah.
still like somewhat related. So,
Mm.
yeah.
Interesting. But yeah, I guess I'm gonna fix them up for tomorrow and like get the end value of each of them. I did get the end value of each of them, but I think that, yeah, like you said, once I correct the values on like the mu null fucking true mean value, or not true mean, but like the value at the bottom chart, standard curve. I think, yeah, we're gonna have more reasonable end values.
Yeah, yeah, it's definitely if you have your two means that close, even to get 60% of the time right answer is like you need like fucking thousands of data points
Yeah.
to have it, you know, nailed down freaking mean. Yeah.
Oh,
Yeah,
interesting.
that makes sense.
Yeah. Yeah, I'm gonna
Oh
just
yeah, so like so I started a new data. If you wanna let's see, if you wanna open that Albion spreadsheet, I
yeah.
can show you what we're gonna do. The
Gordon.
fucking
Mhm.
mosquito bitches are the ones who suck blood, and the mosquito males are like eat fucking pollen and plants and shit. Just the females. It's like working
Draining your
across the
blood and
species,
your energy. The mosquitoes drain your
across
fucking
the
blood.
fucking
The
female
fucking
mosquitoes.
yeah, yeah, the female mosquitoes, right? And the female humans drain your energy.
Life, drain my life.
Yeah.
Anyways, hopefully I stop the leak of my life, and we'll see.
Wait,
But
hopefully what?
I stopped the leak of my life. You
The
know, like
leak of
I
your
stopped the
life?
leak where my life, like
Oh yeah, like if
where
it
my
was
life
leaking.
was
Yeah, yeah,
leaking.
yeah, 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 yeah,
Yeah,
yeah,
it's just, yeah. Anyways,
yeah.
we'll see how that
It,
goes.
I just realized a word like leaking something and something leaking is literally the fucking same. Another reason of why English doesn't make sense.
Yeah. Well, I mean, some things don't make sense in any language. Like, you know, every language has its drawbacks. I don't think there's like a perfect, you know, language.
Yeah,
It's just different with drawbacks, I guess.
yeah.
Anyways, so like so that's so for example for fish oil, like if you put your box like right there, you can read what it says.
Mm-hmm.
You wanna put your box there?
Okay.
So it says you put so if when you use 5 points, if you reject the hypothesis, then you type 1, and if you don't reject, then it's a 0. And then to the right, you take mean of all the points, after treatment,
Mm-hmm.
minus mu 0, and that's what you put here. So for example, like these are random number, like these are random numbers and these are numbers. So I just made them up.
Mm-hmm.
But for example, let's say fish oil was like, if you take the true mean or all data points mean after minus the mu naught, let's say you end up with minus 0.2, which means
Wait, the
health
true
improved.
mean, are we talking right there of the true mean of the null?
True mean, as in you take all the points and then find the average of the health indexes after the treatment, or like on a day off.
Yeah, so
which
that,
is
are you
also
talking about the
means
null?
after.
Like, because like in the null, we're just gonna say mu or true mean will be basically the days before, right?
Yeah. Our null is the way we ask our question.
Yeah.
Null hypothesis versus alternative is we take the average of days before, but this is for true mean of the effect of the treatment. So
Uh-huh.
it's all the points after the treatment. So it's like the mean of the top graph, or the mu of the top graph.
Uh-huh.
Yeah. So let's say, do you understand?
Kind of. I
Well,
mean,
what is it then?
I mean,
You
for
tell me now.
example, okay. So for example, on like fish oil, if we reject, if you're meant to like reject it, you type 1 down below, like type 1 if you reject it, and like then if it's rejected, you try. Well, you're also meant to like type like the true mean, like the value of the true mean, which will be like the average of all the days that you took it.
Minus the mu naught. So
What do you
this is
mean
the
with minus
change.
in
So
mu
like,
naught?
so it's the average of all the days that I took fish oil,
Uh-huh.
minus average of all the days I didn't take fish oil.
Can you give me an example?
Yeah. So
Like an actual real example?
say I'll just do a made up one. So oil. Okay, so then we have like say 1 0 1 0 0.5 0.7 minus 0.2.
Wait, are those meant to be
Zero.
your health indexes?
Yes.
Okay.
So this is before, and this is before, this is before, this is before, and then this is before. So
Yeah.
so to calculate this minus 0.2, to calculate this, you take this. Let's see, this is before. So okay, so this is after.
Yeah, you take the previous days, right? Like the days that you didn't take it. Yeah, like the way in getting the
Yes.
hypothesized mean, yes.
Yeah, so it's like average of these points minus average of these points.
Wait, so you're telling, wait,
And that will go here.
wait, so you will make a minus, like you will subtract when you took it and you didn't take it, and then come up with that?
Yeah, and that will be the effect size. So if it will be negative, that means that this values after are smaller than the values before, which means it's the health improves on average.
Like,
If
okay.
it's positive,
So in this case,
yeah,
you see my box, right?
yeah,
Okay, you didn't take let's say you didn't take it here, right? You didn't take it here. You didn't take it here. Uh, like the day after you took it, like these 2 days, like let's say you took it, you're meant to subtract those two numbers, and then uh, you subtract all those numbers, right? And you get the values, and you get the average, and you write it down there, around here, or what?
So this is the average of all these points. So these points, their average is minus 0.066,
Uh huh.
for example. I feel like I'm supposed to have like 5 points or 6, but I only have 3. I don't know. If you want to like do something to, well, I guess you can. Well, because there's only 3 points here, we're only meant to have really just 3 points here. Yeah. So this is before, this is after, before, after, before, after. And so after, the average of after is minus 0.066. And then the average of before is 0.9, which is the average of these 3 points.
Uh huh.
And then you subtract right here. You subtract this minus 0.06 minus 0.9, and you get minus 0.96. And then you take that and you paste it here. Well, let me see.
But for each single day?
Values.
For each day?
So what?
Wait, what?
Okay, how did I get this minus 0.966?
I mean, you basically get the average. I mean, I think you're meant to get the averages of like the days you took it, you didn't take it, and then you subtract the numbers and you come up with the result.
Yeah, and so it has not. You don't do it for every day. That's the number you put in.
Yeah, yeah. So for all of them, right?
Oh
Like
yeah, I
the
mean you take
average
the
of
average of all of them
yeah,
minus the average of all of them.
yeah. So you take the average of all the days you took it and the days you didn't take it. Like the day before, right? The day before you didn't take it, like even doing with the
Yeah,
hypothesized mean,
sure.
and then you subtract it. You subtract the average. Okay, you get the average of like the days you took it, the days you didn't take it, and then you subtract them like both numbers. You make the subtraction of
Yeah,
those two numbers, and then you come up with the result and you type it in this box, right?
yeah, and so this, yeah, and if on the days after, it's going to be on average a smaller number than on the days before, then the result is going to be a negative number. So if the number is negative, that means the health improved on average after the treatment.
Yeah, yeah.
If it's positive, then that means that the values after treatment are on average higher than the values before treatment, which means the health became worse after treatment on average.
Mm. Okay.
Are you recording?
Yeah, I
Okay.
am.
Okay. So and so then this will tell us if we're correct or not. So this will tell us, let's say for fish oil, since it's negative, that means it's very beneficial,
Although,
right? So
could you turn off that area that is orange, please? Could you change the color back to white?
is that like bothering your eyes?
Yeah, yeah. Oh, that's so much better. Thank you.
Okay, sure. Let's see. Um, so if it's negative, that means fish oil is very healthy. On average, health index improves, and so if we do the hypothesis testing, we want to reject the null hypothesis that fish oil is neutral or bad. So,
Yeah.
but here we write what we actually got. So when we just use 5 points, we write here if we rejected it or didn't, and then here we can see whether or not we did it correctly. So here we rejected it, and it was correct, because we rejected the null hypothesis, meaning that we accept the alternative hypothesis that fish oil is healthy. And when we use all the points, we see that fish oil is actually healthy if we use all the points. And so then here I have like an equation that will basically count them. And so like here out of these three, only one time did we do our testing correctly. So here, for example, arginine, so the effect was 0, which means on average the health didn't improve after treatment. But we rejected the null hypothesis at 5 points, which is not correct, because it was neutral in this case. And so then there's one here, it just counts it as one time we were wrong. It's in this case it's a type 1 error. We accepted the we accepted the alternative hypothesis. We rejected the null hypothesis when we shouldn't have. So that's type 1 error. But here I'm just gonna count them together, type 1 and type 2 errors together, because both of them are bad. Like we don't want to, eat arginine when it's bad or neutral, and we also don't want to miss out on fish oil when it's healthy. So both sides are, important for us. And then, for example, alcohol here, let's say it's 2, which means it's like very unhealthy, for example. And then here at 5 points we didn't reject the null hypothesis, and that was correct. We didn't reject it, which is 0. And when we use all the points, we can see that we did it correctly, because when you use all the points, in truth it is unhealthy. And so this is not a type 1 or type 2 error. We did it correctly. And so then we'll just keep going, and then like when we have like say 10 of them, or 12 variables, we'll see how many times we did the...
For like false or like false, it will be basically if we do not commit any type of error, right?
Yeah, it will show false when there's no error. It will show 1 when there's an error, like type 1 or type 2, and then we can just fucking like we can sum this. We can just do like equals sum. Yeah, we can just do an equation that will sum this whole column, and then it will count all the ones, and it will sum them, and it will tell us how many times we were wrong, and then we'll just divide by total.
So this false or like false, it's been programmed to pretty much write itself once you write the values in like reject and all, and determine at max.
Yeah.
Oh wow.
Yeah. Yeah, like 0. So 1. Well, yeah, I mean that's correct. So let's say.
Did it take you a while to do that, or like it was easy?
No, it's a short. It's a when you put your box on there, you can see the line up top.
Yeah, I saw it.
Just like it's not too long. I mean it just fucking took me a minute just to write it up, write it.
Wow.
Like okay, so like see, bam. Well, except that it shows 0. Well, it shows exactly that, but I mean I can just fucking. Let's see. I can just say 1 and then control copy. Yeah, see, I'm still fixing it. So
I have a question though. When so
correct.
So that basically.
1, bam.
So how we did like in I don't remember which one was it. I think it was arginine, or arginine, that it came out like unhealthy, and we ended up using for the null hypothesis healthy, I mean unhealthy or neutral, and that pretty much gave us the result that for the null hypothesis that it was like right. Am I meant to use an unhealthy or healthy null hypothesis based on the result of the t-score? Or like in all of them, I should just go with like null hypothesis, unhealthy or neutral.
It's null hypothesis, unhealthy or neutral. Yeah. So for this case, you use the same the same for everything.
For all of them?
It's a bit, yeah, for all of them, including arginine. So I mean, arginine, when we do our hypothesis, unhealthy or neutral on arginine, we will not be able to reject the null hypothesis, right?
Yeah, yeah.
So and that will be correct because,
Wait,
like, let's
but
see,
in one of them you told me to
here.
do it the other way around. Like, what are you telling me?
Yeah, for the type 2 error calculation thing. I mean, let's see. I
Oh,
mean, you don't really have to. I mean, you can for fun and just to see some extra information, but it's just like an extra project. It's not really related um,
yeah, like it will
to
in
this.
reality not really mean anything if we get like the like if we put like unhealthy
Well,
or
I mean, it will
unhealthy.
mean something. No, it will mean something. So for fish oil, it's the type 2 error will be the risk of rejecting, or the risk of not rejecting null hypothesis.
Yeah, yeah.
And for arginine, if you do it the other way around, it will be the risk of not. Uh, let's see. Hmm.
I mean, realistically speaking, based on what I'm like seeing, as long as we have like the deep value and the information, the deep value is
Yeah,
just
I
like a
guess
side
arginine.
project. Like, I mean, the type two error is just like a side project, just for like statistical purposes. But once you get,
No,
you sure?
no. Yeah, our type 2 error is gonna be ultra important
Hmm.
because we're actually gonna use type 2 error to see if my method is better or worse than using t-test, because t-test assumes a normal distribution. So if we get smaller type 1 plus type 2 error using just simulation, then it will obviously show that that's much better test than just using t statistic, because we'll see what's our type 1 plus type
Well,
2 error.
then
How often are
then
we wrong?
basically, if I wanna like check the type two errors or whatnot, that means I should keep using like for example, if I get like a healthy value, make sure that the null hypothesis that is healthier or neutral, and if I get like an unhealthy value, is that the null hypothesis is that is unhealthy or neutral, so that way at the upper part we can tell whether it's a type 2 error or not, like in the alternative hypothesis.
I mean, to be honest, it doesn't really matter like what we use, null or alternative. So, for example, for alcohol, we can use fucking null hypothesis it's unhealthy, and the alternative hypothesis is it's neutral, so we don't have to worry about it, or it's healthy, so we should actually use it, because for alcohol it takes more time to like cut it out versus or for arginine or something else, it
Wait, so that
takes
part can I do it however I want, like in terms of like null
yeah,
and
it's
an
fine.
alternative? Okay, fine.
So what type 2 error is and type 1 error is when whatever you decided your null and alternative hypothesis is, like whatever you decided, like it can be different between all of them. If you incorrectly rejected your null hypothesis
Yeah, yeah, I know that.
based on all the data points, that's one type of error. If you like incorrectly, like, yeah, it's basically whether or not you rejected your null hypothesis correctly or incorrectly, you made a mistake,
Yeah, yeah, I
whatever you
know.
decided your null hypothesis to be. So the null hypothesis can be different between all of them, but
Yeah,
the type 2 type 1 error is whether or not you rejected it correctly.
yeah, yeah. No, but like,
Yeah.
for example, if you have like kind of like very similar values, and they end up like in the same spot, you will not be able to reject it, or like or like you could not give an example of like a type 2 error in certain circumstances where for example, like, obviously, you say, for example, right? This one, okay, the null hypothesis is healthy, um, or unhealthy, right? Or so, I mean, or equal, or like neutral, sorry. And it ends up in the unhealthy side, right? And in the upper one, it also ends up in the unhealthy side. Like, you cannot really make a type 2 error out of it.
Uh, yeah, when they're really close,
Yeah,
it's
yeah.
like 50% of the time it's gonna land on either side of it,
Yeah,
or
that's
like
what I was saying.
55% of the time.
If
Yeah.
if like the purpose is actually, get type 2 error every time, like in those examples that he was doing, it's like, he was try harder to get a type 2 error. That's why he was like displaying it. That's what I'm trying to say.
Yeah,
Like,
like
he
he
was
said,
setting
like,
up,
let's say, I don't know,
he
what
he
was it?
he, he was setting up his values, so they had like a type 2 error. That's what I'm trying to say. And if we want to do that, that's possible. But like, uh yeah, I don't know, like the null hypothesis meaning and the alternative hypothesis meaning, they do have value in terms of whether you want to come up with that type 2 error or not.
Yeah, I mean, they will, it will affect the type 2 error depending on how far or where you ask your question,
Yeah,
how
yeah,
far from the
yeah, that's what I'm
truth you
telling
ask
you.
your question.
Yeah, that's what I'm telling you. Like, the
Like,
saying the null is
yeah,
this, or the alternative is this, it does pay, it does have like, has like a huge uh importance in the result.
yeah. Yeah, I mean, and we can just use that type 1, type 2 error to compare methods to see which method is more often correct. So like we'll have our type 2 plus type 2. So let's say if there's like 10 of these things, and
Yeah,
like 3 times we were wrong, then that means our type 1 plus type 2 error is 3 divided by 10 times 100, or like 30%. 3 out of 10 is 30%. So like if out of 10 variables, 3 times we were wrong, then that's 30%, type 1 plus type 2 error of
yeah.
30%. And then like if we use another method, then it's only 2 times wrong. Then that's obviously a better method.
Okay.
Yeah. I mean, I was gonna also do like for the just using the z-test and compare that to t-test and then compare that, but I'm like, we already know that we're supposed to be using t-test, so there's no argument, that t-test is better.
Yeah, I mean, I think that if we were using like samples of like, 300, 200, yeah, the C distribution is better. But, for the values, or like the sample sizes we got, it's too small to use the C
Yeah. So
distribution.
there's no question that t-distribution in this case is what we're supposed to be using versus the z-distribution or z-test.
Yeah.
Yeah. Okay.
Um. But yeah. But I mean, before we switch the subject, am I tweaking, or actually, like, in this case, the concept that you want to give, or like the hypothesis that you want to give to your null, and to your alternative, withholds like a lot of power and importance in terms of like getting like an actual, type 2 error? Like, I think it does. Or you were just going along with me? I think like it does, doesn't it? Like, if you actually are determined to get the type 2 error, because you wanna make sure
So
that the
like
null
for
it's
example,
accepted, and in the top one, it's not.
no, we don't. We don't care. Like we don't adjust our question based on the type 2 error, because our question is based on, is it better or worse than the health index before treatment?
Yeah,
And
yeah.
the health index before treatment is our mu naught. So like for like fish oil, for example, the true population will be quite a bit to the right, and therefore our beta, our type 2 area will be much smaller, because the fish oil has a pretty good effect. It's healthy, it's pretty healthy, and it has a pretty big effect. So the true population would be quite a bit to the right.
Do you like the percentages that I'm using for, like, the alpha and like the beta, or like not? Like in the bottom one I'm using like 50-50, upper one I don't know, I'm using something like 65. I don't
But you're
remember.
not using 50-50 in the bottom one.
Yeah.
I don't know what you mean by I don't know what you mean by using 50-50 in the bottom one.
Like the confidence level is 50 and the other one was in the bottom standard curve.
Well, the alpha we're using for the bottom one, usually in all the times when it was correct, not the times when you were like, okay, I got it corrected. It was like what, 70%?
Yeah.
No,
I
not
did
70.
it.
I guess for alpha it's 30%.
It was 30. Yeah.
So it's not 50-50. It's
No.
not 50-50. It's 30%.
No. But in the last ones that I've been using, I used 50.
No,
for
that's
the
not
bottom
correct. I mean, that doesn't even really make sense. I mean, the alpha is supposed to be, like something small. Like usually, like with a lot of time and money, people use 5% for alpha, right? But we're just want to eyeball things, and so we're using 30% for alpha.
I don't think that the 50 percentage is incorrect. Like anyone can pick whatever they want, I believe. But like, yeah, 70
Well, that's
seems
basically
reasonable.
that's basically how sure we are. So if we're 50-50 sure, 50-50, like maybe it's true, maybe it's not true, but like it doesn't really make sense for us to answer questions with a 50-50 answer, right?
Okay.
We want to be at least 70% sure.
Okay. So for the bottom one, you want to use like the 71 on all of them?
Well, alpha of 30%. 0.3.
Yeah. Like 70 confidence level CL and like alpha of 30, and the top one, you know, go the one that I
And
use.
the top one, in the top one, like you calculate your beta. I mean, you don't really use the beta, you calculate it. Because your beta will depend on your T critical in the bottom one. So wherever T critical in the bottom one lands in the top graph, everything to the left will be the beta. Whatever is to the left, that will be the beta. And then somehow you're supposed to calculate it.
Wait, are you sure about that?
Yeah, pretty sure.
Wait, can you show me
Yeah,
that part?
100% sure.
Can you? I'm confused. Can you show me that part?
I mean, so you have the bottom graph.
Yeah.
Like let me see. Like once you place your bottom graph and the top graph, like you place them without taking into consideration beta. You place them based on where they land, their values.
Yeah. Of course, you
Right.
you align them, but like
Yeah.
the upper chart
And then
can be
you
whatever
align them.
confidence level you want, I believe, and like.
No. So once you align them, not taking into consideration beta, you align them, based on where they align, and then you draw the vertical line. For example,
Are you sure about that? Can you show me like an example?
Well, I mean, let me see. Let me open the. Okay, so let me share screen, I guess.
Can you send me a link so I can watch it too?
Hopefully, as long as you can understand me.
Yeah.
Z. So now the type 2 error is 0.07 or 7%.
Okay, I'm watching
and
it.
the power is 0.93.
So are you at the 1256 point?
So we go ahead and start.
Okay, so you can see. So
now we'll slide it all
so
the
you
way
align
over
these
to
two
a Z
graphs,
of negative
right?
2.
Like
Mhm.
you don't
So
take
our
into
beta
account
is
beta.
0.02.
You don't know or don't care about the beta or
Yeah,
power
but
when you align them,
where did he
right?
ever say that, yeah, like they have to correspond to each other, like the C critical value have to be with each other, but where does it say that, for
Yeah.
example, like this critical value, the upper chart has to be this percentage?
That's where, because that's the area under the curve to the left of that line. So you draw that vertical line from the Z critical to the top graph,
Yeah, but seems like
and
he just
everything
picked
to the
like
left of it,
uh-huh.
everything to the left of it under the curve is the type 2 error, and in this case is beta equals 0.0001. So that beta comes out, he calculates it from that area under the curve. I mean, I guess, let's see, would that be p-value? That's basically the p-value, is how you the way you calculate p-value, everything to the right of the Z critical, but in this case it's to the left, and here the Z or T value he uses would be what, like, I can't really see what's his axis, where it lands in the top graph, but it's everything to the left of that vertical line under the curve, which is just 0.001, or 0.00001%
Yeah, but
of
how
the
does he
beta.
calculate it? He doesn't say.
So that's a p-value. That's the same way you calculate p-value.
Yeah.
But instead of the Z critical or Z statistic, you use the Z wherever that vertical line lands, because on the top, in the top graph, and then that the p-value is basically will tell you whatever to the left of that vertical line is the p-value, which in this case is 0.001. So this is p-value. P-value equals 0.001.
Okay, can you do a quick example so I can have a grasp of it? Like, I think I understand it, kind of, but can you just do like a quick example?
No, because I'd have to figure it out myself as well, because I don't have it at the top of my, like, I don't have that equation handy, and like I haven't really been using it.
Uh,
You're the one who's been calculating p-values.
yes, yeah, but I still do not understand with the p-value calculation. Okay, so I still do not understand. So are you saying that with the p-value of the upper one, I mean of the bottom one, you will come up with the upper chart, like what the beta uh, is meant to be in the upper one?
So what's the equation to calculate p-value?
To get the p-value, you need the t-value, and then you look it up on the chart, on like the p-value chart, I believe, like the first
Yeah,
number, and then
yeah, yeah. That's exactly how I do it. And here, but here the t-value is where that line lands on the top graph, and then the p-value that beta is the p-value.
Okay.
And so the p-value you get will be percent of data to the left of that black line.
So okay,
And the t-value you use is where it lands on that top graph.
okay. So basically, the p-value at the top should be the beta.
Well, beta is the p-value in the top.
Okay.
It's basically probability of data landing in anywhere to the left, or like it's a percentage of data under the curve to the left of that t-value.
Okay.
Is a p-value, and in this case, that also is the type 2 error as well.
Are you 100% of this one?
Yeah, I'm sure. I'm 100% sure.
Okay. Okay, so correct me if I'm wrong, but like, okay, I get the p-value of the bottom one, and based on the p-value of the bottom one, is like it's gonna meant to be like the fucking the upper part, right? Where I'm meant to like create the beta, which will be, you know, basically the alpha, the beta, the upper part, or probability of fucking
And the
um
degrees of freedom are going to be the same because you're assuming that the shape of the two curves are the same. So the degrees of freedom are the same. When you look for the p-value, you know, you need to know also the degrees of freedom, and it's going to be the same as in the bottom
oh, okay, I see. Could you use like
because you're assuming that
okay, could you use like make a
they're the
quick
same shape.
example on, like, you know, like Paint or something like that? Like,
Well, this is the example we're looking at at the minute 12:56.
but where did
Um,
he ever spoke
I,
about like p-value in this part to come up with the upper
that's how
chart?
you can calculate the beta. That's how you can calculate your beta
Are you? But
because beta
hmm.
is the amount of is the area under the curve to the left of that black line,
Mm-hmm.
black dotted line. And that's also the definition of the p-value, is the area under the curve to the left of the t statistic. But in this case, you know, this is on a negative side. I don't really know how the tables work. I think the way equation and table works for calculating the p-value is, in this case, you're looking for a very small number. And so in this case, let's say here the t-value is like, I don't know, let's see, 0, 1, 2, 3, I don't know, maybe like -3, where the black line is, you know, it lands on like -3 t-value in the top one, right?
Hmm.
Do you see that?
I guess so. But hold on. Okay. Okay. So with the p-value itself, you can like make a chart, like a standard curve.
No, no.
Then
You
what do you
get
mean
the
that?
p-value from the curve.
Yeah, yeah, no, but like with the bottom one, then how do you make the upper one? Like how do you like
Well, so the shape of the upper one is the same shape as the bottom one. Is the assumption here? Like it has the same like, so that's
yeah,
what I'm saying
but
is that
that's what I'm
like
saying.
when you go
Basically,
to the chart.
the upper one, basically the upper one, it can be anything you want. That's you keep watching, right?
No,
The power just changes. Like, but it has to be aligned.
no, no, it can't be anything you want. I mean, he just shows different examples of what if it's there, what if it's here, but it cannot be anything you want. It's specific.
So it has to be like
So
the
for our
same.
case, for our case, let's say for fish oil, it has like, let's say 10 like all like, so we use all the points for the top curve for the fish oil. Let's see. So we have 10 points,
Yeah.
which gives us 9 degrees of freedom. So when we go to the chart to calculate the p-value, we go to the chart for 9 degrees of freedom
You mean
for the
the
t-value.
critical? You don't need the degrees of freedom for the p-value.
You don't need, well, so when you calculate p-value for the t statistic
You don't need degrees
from
of
the t
freedom.
statistic, you don't need degrees of freedom?
Yeah, no,
Doesn't
you need
sound right.
the t-value or the yeah, I believe, yeah.
Yeah, you definitely need degrees of freedom. Let me
You
see.
sure?
Uh, yeah.
Or either that or I don't remember it.
Let's see. One, two. Yeah. The degrees of freedom is freaking left column.
Is it? Oh, I forgot that.
Yeah, you absolutely need degrees of freedom to calculate the p-value.
Oh,
Because
interesting.
because it's different based on, you know, the degrees of freedom basically gives the shape of that distribution
Oh, okay.
of that curve. You know,
Okay.
your curve will change based on the
Okay.
degrees of
Continue.
freedom. So, so you get your bottom curve, you get your T critical.
Yeah. Let's say 70
You
30.
align them. You align it with the top. You align top curve with the bottom curve. Like
Yeah,
for
but
the
what's
top
gonna be like
curve.
the top one if we have 70 30 at the bottom?
Well, you calculate what is the T statistic, I guess, of the mean value of the top curve. So let's say, you know, the fish oil is like minus 2. You know, the x of fish oil is -2. So you calculate the t value for that for all
You mean the
points,
D critical or what do you
and
mean?
let's say t value.
Yeah, but like the D values are meant
So
to be
t
the
equals,
same
you
for
know, x
both and the
minus mu.
bottom one.
So the bottom one is using like 5 points, and the bottom one has a mean is centered on 0, right? Is it
Okay.
centered on 0?
Yeah,
Like
yeah.
that's the t value, so the t equals 0. So the bottom one is centered on t equals 0, right?
Uh-huh.
Are you there?
Yeah. Can you hear me? Can you hear me?
Yeah. Yeah. Did you understand what I said?
I believe so.
What did I say?
That you know you basically calculate the D value for the upper one and the bottom one.
No, that's not what I just said.
What do you say? Say it again.
So the bottom curve is centered on t equals 0. Is that right?
Yeah. Both of them are.
Like the center of the bottom curve.
Yeah.
No, I mean, in relationship to the bottom one. So the bottom one is centered on t equals 0 for itself.
Okay, I think I get it. If I'm not mistaken. Okay, so you basically use the upper UA, like I mean the mu A, and the like for example for the bottom one you use a mu uh uh O, which would be like our null hypothesis. I mean our null um domain, and the upper one will be or fucking mu alternative main, and basically you use those
That's a
values.
retarded. That's a retarded naming. Like that's completely retarded naming.
Okay.
It's not alternative. It's the true. It's like so the
Okay.
bottom one is our hypothesis and all that. The top one is like basically mu true, like the true mean.
Okay.
Or the true mean that you think it is, and then you're trying to figure out how many samples you need to test it. But it's the true mean. Like if you
Okay.
use enough data points, you that's the value you'll come up with.
Okay. Yeah. Okay. But basically, are you implying that I grab that and like those values, or for true mean and the bottom one or mu null, and for each of them, I get the t value of them just using like the standard formula, and based on the result, it's where I will end up putting the the fucking the values, like the t values, like where it's meant to land, right? And the p value is gonna be the one used to create the upper standard curve, like the p value of the bottom one.
So it doesn't sound right. So the bottom one is so it's centered on t equals 0, right?
In
Now,
what
the top one,
time frame are you right now of the video?
1256.
Okay.
So the bottom one is centered on t equals 0, right? Like
Uh-huh.
I think it's always centered on t equals 0. Right?
Yeah, yeah.
Okay. So then for example, for fish oil, the mu true, we come up with like, let's say, like minus 0.2.
Uh-huh, for like the t value.
So from that we for the x,
Okay.
or I guess it would be x minus mu. Yeah, I guess x minus mu would be minus 0.2. And then for that we calculate the t statistic, because in that equation, there's a t, there's a x, and there's a mu, and we know the x minus mu, it's minus 0.2, for example, and then from that information we only have one unknown variable, which is t value, and then we calculate the t value.
Uh-huh.
So that t value is going to be the distance from the center of the bottom curve to the center of the top curve.
Uh-huh.
So let's say for minus 0.2, that's a t value of, let's say, what is it, like 1, 2, 3, 4. Let's say it's a t value of 4
Okay.
for minus 0.2 x minus mu naught. So that means 1, 2, yeah, 4. So that means that the center of the top curve is 4 units to the right of the center of the bottom curve, because it's t. So the center of the top curve, which is minus 0.2,
Cool.
corresponds to t equals 5, which means it's, or 4, t equals 4, which means it's 4 units to the right of the bottom curve. That's how you position it if you're positioning them.
Okay.
And then
I'm still a bit confused
so-
on the upper, like, yeah, I don't know. I guess I'll just rewatch this and hopefully I'll get it, like, rewatch this video. But continue.
yeah, rewatch it, and then just watch other people talk about what's a type 2 error and how to find it. After you watch maybe like 3 different people, you'll have more information.
Yeah, yeah. I mean, yeah, for sure.
Because they'll all have their own spin. They'll all have their own spin on it.
Yeah, I guess so. But the only thing that, I think is like confusing me as fuck is like the fact that, the upper like okay, could you just like give me an example on like paint? It doesn't have to be professional or whatnot. Like, for example, if I give you like the values or like with made up values, could you just like do it really quick?
I don't know that equation. What's that equation to calculate the t value when you have the x minus mu naught divided by, I guess, standard sigma divided by square root. I fucking memorized it by now.
I can give you the formula.
Pretty amazing.
I can give you like the formula.
I memorized it. It's t equals x minus mu naught divided by standard error divided by square root of n.
Yeah, I can. Yeah. You just do it, and yeah. Can you just like do it really quick?
Okay, fine.
That will like help me a lot. I'm not trying to put you in an uncomfortable position. I just want to learn myself too.
I don't think it will. I don't know if that will help you, but we can try it.
Okay. Example, you can use like any numbers for like the sample, mean, sigma, all that, and come up with like an example of how to come up with like the levels of the upper standard curve. Like, I mean, the confidence level and the beta that we're gonna use. Yeah.
So that's your
Bottom one. Yeah, but what's the
That's the
confidence
bottom
level?
one.
Okay,
And
okay.
then- So let's see. So this is man, I'm using a fucking mouse thing, the mouse pad, not mouse pad, like on a laptop without a mouse. Let's see, where's the text here? Is this text?
I think it'll be easier
Text,
if you
yeah.
use Paint, but up to you.
How would it be easier?
Oh, okay. Because like the screen.
0. So
Yeah, but what's the
So that's
confidence
that's
level
a
of the
0.
curve?
Okay, that doesn't make sense. Are you looking for alpha, degrees of
No, no, no.
freedom, or what?
Like
The degrees of freedom shape the curve, as far as I know.
no, 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 no.
Every
But
like, there's,
I'm trying to like look up for like how the upper standard curve is gonna be proportionate compared to the bottom one, and you need like the confidence level and all that, the alpha, so you can come up with like the p value, I believe. Like yeah.
so this is t value. This is x axis. This is the x axis, and it's the t value. So this is
Okay.
t equals 0.
Okay.
Okay, so like let's say we're looking at fish oil, or
Yeah.
I don't know. So let's say we're looking at our 30%, so 30% alpha.
Okay.
So alpha is also p-value, just so you know. Like p-value where, like, so this, like everything to the right of this line, to the right of this area
Mhm.
is alpha is there's 30% of the data in this area. There's 30% of the area of this curve is in this, to the right of this line.
Yeah.
And that's also if this line is, say, t equals
No,
1,
but
then it's this is p, this area equals p-value of this many degrees of, let's say, 7 degrees of freedom, which means we have 8 points. You did something. So degrees of freedom is 7, which means it's 8 points. Can you hear me?
yeah, I'm watching.
Okay. So if you go to the table for 7 degrees of freedom, t statistic of 1, it will give you a p-value. You can find p-value just from the 7 degrees of freedom and t equals 1, and that p-value will equal alpha. Because they're both, alpha is a p-value. It's the area under the curve to the right of this line, t equals 1.
Wasn't
So
it?
both
Mhm.
beta and alpha is a p-value.
Wasn't it like like the critical and the p value, the ones that are related?
Well,
Not alpha.
every t-value has a p-value. For every
Yeah.
t-value, there's a p-value. So for t critical, there's a p-value. For any other t-value that you draw here, there will be a p-value, and that p-value will be the area under the curve to the right of it.
Okay.
So if our alpha is 30%, it will end somewhere here. For example, t equals 1.
Yeah. Okay.
And then if you go to the table, then, for example, to the 7 degrees of freedom and t equals 1, the p-value for that will be 30, or 0.3, which is
Okay.
also our alpha.
Can we look at it? Can you open like the p value table?
Well, I don't know exactly I'm guessing t equals 1, I'm just kind of eyeballing it, let's say
Okay. Yeah, but
30% of the
could
data
you open
here.
it just so I know how like do the procedure better in terms of like the procedure of how to do like the p value. Already believe I do know it. But like I just want to be able to see how it's done in the upper one.
So let's say 7. Okay, so what is this type of test? One tail. It's p-value. So 7 degrees of freedom, and then our t statistic for for 10%. So it's this one only goes to 10%. So this is 0.1 p 0.1, which is a fraction. So 0.1 fraction is also the same as 10%.
If I'm not
So
mistaken,
0.1 is 10%.
if I'm not mistaken, like in a video that for example I watch, like you get like the D value, like the D value will be basically or like the C score, and then you find it on like those values for like 2.600 blah blah blah, and then to get the P. Wait, or am I confusing it with the T critical? No, no, no. I'm kind of fucking tired right now, but like I think you're meant to look it up in there, right? Like the 4 digits numbers, and then you look at the left and the upper values, and then you come up with it.
I mean, I think you just need to like spend like 2-3 hours just watching other people explain it, and maybe rewatching Brandon,
Okay.
because I feel like that will be better use of my time.
Yeah, but are you sure it's this way? Like the way you get the P value?
Yeah.
Okay, well, okay. Now,
Yeah, you just gotta rewatch it and then watch like 3 other people explain, or type 2
okay,
error.
okay, okay. But can you go back to the chart really quick? Okay, let's say random P value. But go back to like Paint, please. Okay, okay. Let's say that it's like the P value. Okay, now how do we end up coming up with the upper chart values in terms of like the alpha and the confidence level
So,
and all that, power level and beta?
so, so let's see. So what is it? T equals fucking x minus mu divided by sigma divided by square root of n. Let's see. Right? Is this right?
Yeah, yeah.
Okay. So then we have our for fish oil, T equals minus 0.2 divided by sigma, which we know, divided by square root of n, which we also know. So we calculate our T. So let's say our let's say we do that and we get T equals 4, right?
Yeah, yeah.
So then we find where is, so this is really for just for like graphic purpose. I mean, just to draw shit. So then you have T1 there. Let's see. Need where is this? Okay, there. So T1. So then there's T2, T3, T4. So this is T4. T equals 4. Oh, this is 4. So this is T4, right?
Yeah, yeah.
So that's where the top curve will be. Is at T equals 4, because x minus mu for fish oil is divided by all that corresponds to T equals 4, and that's how far it will be from 0. So that's where you draw this top curve. So the top curve will be decided based on this equation. You can draw it wherever you want to. It will land wherever this equation says.
Okay.
And then your T critical.
Okay, but like, how do you
is
determine like
here.
the values there? Like, in terms of how do you know that the beta and the confidence level is gonna be that? Like, you just
So then you can so then your beta equals whatever this area is. This area to the left of this line under this curve. So it's the area under this curve to the left of this line.
oh, okay.
Yeah, but since since this curve is symmetric, it's also area to the right of this line. Which
Okay.
like, let's say if this is 1, if this is T equals 1 and this is T equals 4, then the distance between this 4 and this 1 is 3. So this will be minus 3. t equals minus 3, and this would be t equals 3. T.
Okay,
And so
so
to get the area under this curve, I think you calculate the area under this curve past t equals 3, and the area under this curve is the p-value. And here you know everything. You have 7 degrees of freedom, t equals 3,
yeah.
and then from that you calculate your one-tailed p-value, and this one-tailed p-value is your beta. The beta is area under this curve, or under this curve, but it's the same. This area under this curve is the same as area under this curve because it's symmetrical.
Okay. I think I get it. Yeah. Okay. So basically you're implying that in reality we only need like the t value to come up with the upper chart. I mean the upper standard curve.
Yeah. Well, and degrees of freedom. I mean, you can use 7, or you can use all of your points. I think I'm not sure if you're supposed to use 7 or all of your points. I mean, you can try to answer that question. But yeah, I mean, it sounds like you should spend like 2-3 hours still rewatching that, Brendan, and then watching other people explain it. So you'll know, you'll get you'll know more about it.
Okay.
And there'll be more likely that you'll do it right.
Yeah, for sure.
But yeah, so then you have your degrees of freedom. If the shape is the same, then it's 7 degrees of freedom. And then you have your degrees of freedom, the t-value, and then you that's all you need to get your p-value from the table.
Yeah.
Mathematical equation.
Um.
There you go.
Okay. Yeah. I think I get it. 70% sure. So basically, where your t value lands is where you're meant to start like the chart, like the middle part, right? Like for example, you see like that 4 in the bottom.
Yeah.
It's where our chart will
Yeah.
will
Yeah.
start.
Yeah. That's the center of the top chart.
Okay, I get it.
Yeah. So you don't get to pick where to put it. Your data. The true mean will tell you where it lands. And then that's why your beta will be determined from that.
Oh, okay.
Type 2 error. The farther this curve is to the right, which means the more effective fish oil, the more the effective fish oil, the farther this curve to the right, the smaller the type 2 error. And if you put them on top of each other, the type 2 error will be huge. It will be like 50-50. Like you every time you take your sample data, there's 50-50 chance that you will reject or accept your hypothesis, because the area under the curve will be so big, because this curve will be on top of this one, so like this whole area will be to the left of this line.
Okay. I get it. What I was gonna say. By the way, do you mind? I'm kind of like, I got it, I believe, and I got the rest of the information you told me, but yeah, I'm gonna do my research and stuff. Do you mind if we do like the health related stuff for tomorrow? Because I'm kind of feeling very, very fucking like groggy. Well, not groggy, like um, sleepy and tired. Like, can we do like the health research tomorrow morning? Like, any time for you?
Yeah, that's fine. Or sometime tomorrow.
Yeah. But are you fine with that or not?
Yeah, that's fine. I mean, there's
What? Yeah. You cool?
yeah. I mean, like if you're really tired, it's much better to wait until you're not tired.
Yeah. I'm kind of tired. That's why I wanted to do it like earlier.
Yeah.
But yeah, okay. I get it. I think I get it. Thank you for the explanation, and sorry that it took me a bit long, and I appreciate that you took the time to explain me, Broski. I appreciate it.
Yeah. Cool, man.
Yeah. Right. In this case, here is where, or like, you know, the way they're aligned, like this way is where it should like start, like, you know, the chart. I mean, the standard, not the chart, the standard curve should start like something like this. And like,
I don't know. You have to calculate the t value.
no, but with the t value, like this is t
You don't.
value.
You haven't. Or have you?
Yeah, like T1 here. The t value of the lithium ended up being like
Okay.
negative 4.69 with 6 points.
Of all points.
6 points. Because you told me
Yeah,
to
but
use
you're gonna
6.
be using all of your points to get the mean of that. But you to get the true mean, you use all points.
Okay. So, uh, you know, for lithium, you want me to use all points? Like to get like the t value, you want me to use all points in all of them?
No.
Oh, oh, like, are you telling me that, you know, the bottom t value and the upper one are gonna be different?
So the bottom one is centered on t equals 0.
Yeah.
The top one is centered on t, whatever your t is when you calculate it. Yeah, it's going to be different because you're going to be using all of your points to calculate the t for the t value for the top curve, and that will be this where it will be centered in relationship to the bottom curve.
Oh, okay, I get it. Okay. Okay, I get it. Yeah, I think I get it.
Yeah, yeah.
Um, okay, I get it. So, in other words, um, for our sample or like our true mean here, the formula that I will be using in the x, right? I will be using all the points to calculate the t-value of the upper one, and in the bottom one,
Yeah,
I will only use the amount of points that I'm using. Like for example, 5 here. Only use like 5 samples size to calculate the t-value.
Well, I mean, you use the t value for the top one to find where it's centered in relationship to the t equals 0.
You mean
Of
the
the
bottom
bottom
one? He started with the bottom one. Why will we
Well, the
start with?
bottom one.
Uh huh.
Well, the bottom one is centered on t equals 0.
Uh huh.
Yeah, so the bottom one is centered on t equals 0, and then you calculate the t for the top one to see where it's centered in relationship to the bottom one.
Okay, and then you align them.
Yeah, I guess.
Okay. Okay, I think I get it. Is that what I'm?
Yeah,
Am I correct or am I not? Okay. Yes or not?
yeah, and then, yeah.
Okay. What?
You know, you said is, and then and we align them.
Like,
Yes, you're correct. We align them.
yeah.
That's perfectly true.
Yep. Yeah. Okay. Yeah, yeah. And then yeah, okay, makes sense. And what I was gonna say, yeah, then we align them, and for example, where or the chart. Wait, I have a question. What do we exactly do when, you know, when like the t values that we end up getting are like outrageously fucking, you know, high in numbers, and you know, we only have like 1 2 3 1 2 3.
Just estimate where 5 or 6 is.
Yeah, yeah, that's what I've been doing, I guess. Okay, well, I think it makes sense.
Yeah.
Wait. Okay, so if 5.
Okay, man. I think okay, no more questions. Like anything else, you gotta figure out yourself.
Okay, I'm gonna okay, I'm gonna figure it out
It's
myself.
already been like
2
3
hours and a
hours or
half.
something,
3 hours.
yeah, just talking about the same thing.
Yeah, okay. Yeah, I'll figure it out myself then. I'll
Yeah,
talk
sounds
to
good,
you
man.
later. I mean, yeah, when I wake up. Alright, see ya, broski.
Okay, later, man.